Vanakkam Makkale, and welcome back to another episode on Konjam Mokka with Science. Now, as we were all taught in school, all things are made up of matter and atoms are the building blocks of matter. But before we dive in deeper, what is an atom? Well, for a rough visualization, if the Earth is one giant atom, its nucleus could fit inside a baseball stadium. Everything outside the stadium, even the rest of the planet, well, that's where the electrons live, in a sort of wavy, quantum-y cloud. The stuff that makes up stuff doesn't actually contain much stuff. Who would have thought? But if an atom is just a minuscule nucleus surrounded by a wavy, quantum-y cloud of mostly nothing, kinda makes you wonder, why does light whoosh right through the atoms and break steel or chocolate? Why aren't you and I transparent? So why aren't we transparent? Well, we are. If you're an X-ray, our bodies just aren't transparent to visible light. Of course, visible light and X-rays are both just different forms of electromagnetic radiation with different wavelengths and energies. So what's the difference? Well, have a seat because class is in session. See what I did there? I said glass instead of class? Okay, never mind that. Glass is transparent to visible light. If we zoom down to an atomic level, we see that glass is made up of a bunch of silicon and oxygen atoms, same as sand. When the sand is melted down into a liquid, those molecules left the nice, perfectly repeating crystal shape they were living in and went wild. Until we cooled them down really fast, they froze in place in sort of an organized jumble. All those atoms are surrounded by wavy quantum-y electron clouds, but the electrons around a nucleus just can't be anywhere. They live on specific energy levels. Think of them as different distances from that tiny nucleus. And when a photon comes by with exactly the right amount of energy, it gets absorbed, bumping an electron to a higher energy level. But if the photon doesn't have just the right amount of energy, it passes right by. Imagine I'm an electron. I'm hanging out on the ground at a low energy level. I want to move up to a ledge to the higher energy level. To make it happen, I have to have just the right amount of oomph in my jump. Too little, and I don't make it. Too much, and well, I go way beyond where I need to. Just right, and I get there. For the particular atoms that make up glass, the energy levels are so far apart that visible light doesn't have enough energy to boost those electrons up to the next level. That's why visible light passes right through. But photons of UV light do have the right amount of energy to power up those electrons, and they get absorbed, which is why glass is opaque or hazy to most UV, and why it's hard to get a sunburn through a window. How transparent something is depends on this relationship between the light energy and an atom's electrons. Different elements have different energy requirements for their electrons to absorb light. Like how when visible light hits my atoms, it's absorbed. Some light might get through the top few layers of skin cells, but within a few millimeters, all the photons get gobbled up. And that's why I'm not transparent. But hit me with higher energy waves like X-rays, and I am transparent. Glad we cleared that up. But no, not this time either. Fine. But think about how atoms are wavy, quantum-y, mostly empty clouds. Makes me wonder something else. Why am I even here? Why aren't the mostly empty atoms in my feet passing right through the mostly empty atoms in the ground, sucking me into the Earth's superheated iron core? Why can't I sit in a chair, kick a ball? Why can't I touch anything? Let's say I want to touch my right index finger to the left. Both my index fingers are made up of about a gazillion atoms, give or take a quadrillion. And all those atoms are surrounded by negatively charged electrons. As the two objects get close enough together, the negatively charged electron clouds at both surfaces repel each other, thanks to what's called electrostatic repulsion. The actual contact itself, the sensation of touch, is caused by an actual force from the repulsion acting on pressure-sensitive nerves in my skin. Kind of like how we're never really aware of the atmosphere until there's wind pushing against us. Touching something doesn't really mean decreasing the distance between me and something else to zero. It's just getting my atoms and that other object's atoms as close as the electrons and physics will allow. Of course, there's one more way that electrons can interact. It is actually possible for two negatively charged electrons to occupy the same quantum cloud energy level, as long as they have opposite directions or signs for a property called spin. And sometimes electrons in two different atoms can be squished close enough that their waviness even overlaps. That's the reason covalent chemical bonds exist, which is pretty convenient. Like the ones in our body, all those molecules that keep you alive, full of atoms absorbing visible light photons. And just like the bonds between oxygen and silicon, in a camera lens, in the fiber optic cables of the internet, even in the glass of the screen that's between us right now, photons are letting visible light pass right through. Catch you on next week's episode. Stay safe and stay curious.